language educators use statistics?
Thank you for asking. Statistics are an extremely prevalent phenomenon in modern society. And in order to answer a question like that, let's acknowledge some of the ways that statistics are actually used. They exist everywhere. They exist in test scores, such as the test that you may use in your school. They also exist in the form of national statistics, like the gross production of a given country or the amount of times that a given event happens, like an accident on a highway. And they even exist in something as esoteric as hat size. I'm very familiar with that because I happen to have a very large head. It's extremely difficult for me to buy a hat because I'm about 2.5 standard deviations above the mean of men's hat sizes. And to this day, I have a hard time buying a hat. It's a purely statistical phenomenon. There's nothing I can really do about that. How we use statistics is related to what statistics do for us, and they're everywhere in life. And in order to give you some advice about how to use statistics, let me first give you a definition of statistics. I would like to define statistics as systematic description or inference about phenomena in the world through numerical or alphabetical analysis. There are 6 parts to that definition, and as I explain each part, I'll give you advice of how people actually use statistics. The first part of the definition is that statistics are systematic. Systematic transfers or translates into concerns such as rigor, control, and retention and management of data. Statistics is usually associated with some kind of rigorous management and control over whatever it is that you're measuring. This is, in my opinion, something that can be managed at the level of principle. You needn't worry about particular rules of management or particular rules of rigor or control. I think it's something you can deal with in your career at a more principled level. In that regard, I have a book called Principles of Statistical Data Handling, and the reference is given at this website. The second part of the definition is description. Systematic, part 2, description of statistics. Description is essentially basic information about the world, the what, the where, the how. It does not get into the why. That's the third part of the definition. So the simple fact that men's hat sizes have a distribution and that I happen to be somewhat above the average is a purely descriptive phenomenon, which has had an unfortunate impact on my life because it's difficult for me to buy a hat. That's a simply descriptive fact. There's no why about that. I don't know why I have a large head. Let's go to the third part of the definition. The first word was systematic, then description, or inference. This is where statistics gets very, very powerful. Statistics can be used inferentially to make a claim about relationships of things, about a causality even. For example, if you compare 2 teaching methods and look at the average performance of students on a group, as a group between one method and the other and come up to some kind of conclusion. Experimental inferential statistics are often used to make advanced interpretations about the world. The fourth part of the definition was that statistics are often numerical in nature. By this we mean that the representation of the world can be actually numbers, such as what is the measurement of my head, or what was the score that a student achieved on a particular test, or it could be coded where we represent some phenomenon with a number, like political affiliation. For example, here in the United States, if you're a Democrat, you might be coded as a 1. If you're a Republican, you might be coded as a 2. And if you're an independent, you might be coded as a 3. This is purely arbitrary. The next part of the definition is that statistics might be alphabetical. Very often, increasingly often, it is not necessary to code phenomena in the world into particular numbers. We can now handle words and values in statistical analysis. We can actually type in a word like Democratic or Republican, the name of your political affiliation, or the name of the class that you were in school if you're doing a comparison between 2 teaching methods. Group A, Group B, you can actually use those words. Male, female, it's not necessary to assign a code to each term. Finally, let's build the definition up again. Systematic description or inference about phenomena through numerical or alphabetical analysis. What does that word analysis translate to in your use of statistics? Increasingly, analysis in statistics involves computer software. And I'd like to make 2 points about this. First, there are a large number of specialized statistical software packages, and we have some links at this website that can lead you to those. But I would also like to strongly encourage you to look in your own available software. Very often people have software in their computers which can do a lot more statistics than is readily apparent. The lead candidate in this regard is a wildly popular package called Microsoft Excel, which actually has a lot of statistical functionality built into it. Now, I want to mention something called the classical research model, in which a researcher proposes a question based on review of literature, designs some methodology, executes the methodology, and analyzes the results using some kind of statistics, both descriptive and inferential. This is a very popular model to know about the world, to examine the world. In this regard, I'll give you 2 references. The first is my favorite statistics book by Fred Davidson, 1986, Foundations of Behavioral Research. The reference is here at this website. But I'd like to give you a second, even better reference book about the classical empirical use of statistics in research. And the name of that book is simply your favorite statistics book. Probably the statistics book that you learned from when you studied statistics or from which you are studying statistics now. Hang on to that book, because a lot of your learning about statistics is anchored in the book that you first used. Curlinger happens to be the first really good statistics book that I used. As time passes, you might find that some statistics book from which you study is better than some other one. As you pick out which ones you like, hang on to them. That will become the genesis of your statistical library. I'd like to close by talking a little bit about philosophy. It's a little too easy to allow statistics to govern too many decisions in the world. This is a phenomenon called statistical determinism, in which the meaning of something in reality is its statistic. Probably a very good example of this is in language testing, where the meaning of the score or result on a test is a person's rank among his or her peers who take the test. This is something we have to watch out for. Statistics is not a meaning in and of itself. It's a tool from which meaning can be achieved. There are many, many alternatives to statistics, and there are many alternative ways in which statistics can be used beneficially in a wide range of philosophical domains. Please consider pure alternatives to statistics such as qualitative research or ethnomethodology if you are thinking of doing a research project. And also please consider, as you use statistics, it needn't be used in models that you have already seen other people use. Be flexible, be creative, and be adaptive, both in your use of statistics and in your potential rejection of it in your own philosophy of teaching. I think that's about the right place to end.